بسم الله الرحمن الرحيم الحي. أهلا بكم أحبتي وفي درس جديد ومهم جدا في دروس علم المواد أو في دروس علم هندسة المواد، ألا وهو درس التآكل. درس مهم جدا لطلبة الخريجين، طلبة المرحلة الرابعة، يتعلق بكل ما يمكن أن يرتبط بمادة التآكل وبكل ما يرتبط بحالة التآكل التي تحدث في المعادن الفلزية والمعادن المعادن الفلزية والمعادن الحديدية والمعادن التي تعتبر من غير الحديد، كمثلا أي نوع معدن غير الحديد. التآكل صفة يعني موجودة في تقريبا في جميع المعادن، تصيب جميع المعادن على أنساق مختلفة، وتظهر بصور مختلفة كذلك في الطبيعة، أو تظهر في صور مختلفة كذلك ليس في الطبيعة ولكن في البيئة التي تتواجد فيها المعادن لتطبيقات معينة. على المهندس التعامل مع التآكل. نقدم اليوم بإذن الله نظرة موضوعية في هندسة التآكل وأسباب التآكل وكذلك صور التآكل والطريقة التي يمكن التعامل بها مع التآكل. So here we are. Welcome to you here. I'll be up students again here in the new lecture, the further lecture here, the most associated, if I want to be statistically specific here, the most correlated topic here, the most correlated subject or topic here, pretty much correlated to the engineering materials or the engineering material sciences, which is the corrosion, by the way. The corrosion is a very important phenomenon, or a very important aspect to inflict the materials, being non-metallics or even metallics materials, as you can see right here, or ferrous or non-ferrous materials that actually coexist for a certain and ambient applications in the different or various or variety of ambients and ecologies or environments. The engineers will have to do, after studying the lecture here, post to that posteriorly, the engineer will be able to deal with the corrosion and will be able to handle the corrosion mechanisms as well as the kinetics of corrosions, which means which means basically, fundamentally, and principally the tracks or even the courses at which the corrosion is actually going along with. So today, in this lecture, in this brand new lecture we're presenting here, we're going to study everything that actually is associated to the corrosion, the advantages of corrosions, as well as the definitions of corrosions, mechanisms of corrosions, kinetics of corrosions, and the reasons for corrosions, as well as the corrosion protection. So here, as you can see right here in front of you, the material sciences related to the corrosion, chapter 4. The corrosion. The goals or aims or even the purposes after studying corrosions. The purposes of studying corrosions are listed as follows. يعني الأهداف المهمة المستقاة من دراسة التآكل مدرجة كالتالي. After studying this chapter, the intern will be able to define the corrosion, knowing every corrosion, knowing the aspects of corrosions, or even the figures of corrosions, the forms of corrosions, understanding the polar potentials as well as the galvanic cells, understanding the SEMF. The SEMF, the standard electromotive force. فهم القوة الدافعة الكهربائية المعيارية. Figure out the way to of metals assortments. Figuring out the way of metal assortments according to their corrosive activity. Calculating the CCR or the corrosion rate. Have full comprehensions or to be fully known with the means of corrosion, as you can see right here in front of you. The way to figure out the metallic assortments according to their corrosive activity. here and the introduction, which is going to have to say to you, introduction for the definition of corrosion. The corrosion can be identified as the destruction of material as a result for interactions with the surrounding media. يمكن تعريف التآكل بأنه إتلاف المادة نتيجة لتفاعلها مع الجو. The metallic materials may interact or even react with the oxygens O2 or even the acidic materials, as well as the ceramic materials may interact with the molten salts at elevated temperatures, and the polymeric materials may interact with the solvents. يعني المواد المعدنية قد تتفاعل مع الأكسجين أو الأحماض، والمواد السيراميكية تتفاعل مع الأملاح المنصهرة عند درجات الحرارة العالية جدا فقط، لأن المواد السيراميكية تحتاج إلى درجات حرارة هائلة لكي تنصهر، هائلة جدا. So the ceramic material requires a very broad range of temperatures, in order just for them in order to melt, or even in order to dissolve within any molten salts or even within a very regular environment. والبوليمرية كذلك المواد قد تتفاعل مع المذيبات. أهم أنواع التآكل, most essential types of corrosions are the corrosion that actually inflicts materials and the metallic alloys, minerals, or even the metallic alloys, called or termed to be as the electrochemical corrosion, which we will go through by studying here, subsequently by studying here. The minerals or even the metals typically used in the contemporaneous civilizations to manufacture many of items or to synthesize many of items that are actually extremely varianted in their sizes and in their shapes or their forms. In every case, in every situation, the corrosive properties or the corrosion features of metals are of maximum importance or are of maximum essentiality, side by side with their mechanical features as toughness and hardness, in the determinations of their engineering utilization domain. At any domain at which the metallic product surface would be, at any domain at which metallic surface would serve at which the metallic production would serve at, whether in the air or even at the belly of the earth or even under the sea waters. So the product can handle or it can perform functionality safely as long as it does not react with the surrounding air or it does not react with the surrounding media. As you can see right here, at any field or at any domain at which the metallic product would serve at, or at any domain at which the metallic product would serve, whether in the air or even the belly of the earth or under the sea waters, or even the product can perform functionality safely as long as it does not react with the surrounding media. There are actually many of the electrochemical corrosions that actually affect directly or indirectly on the suspensions. As you can see right here for you, most important issues or the most important corrosion lineup or highlights, as you can see right here in front of you, are as follows, listed as follows: the necessity for the units and the corroded equipments to be replaced with further equipments that are actually appropriately functional or even safe, as well as the concomitant of losing many of the, in addition to the, as you can see right here for you. B, the necessity of the periodic maintenance to be applied as dies plating or dies painting of the continuous coasts, as you can see right in front of you. D, the units susceptibility or even the units, the adjacent units to the destructions are exposed to destructions as a result for falling apart of the corroded units, needing more energy or even more requiring more energy to thrust fluid within the tubes as a result for increasing or even as a result for overwhelming friction resistance due to the increasing of the coarseness of the interior tube surface due to the corrosion action, or the interior due to the coarseness of the tubular or even the tube linings due to corrosion action. studies in mid-80s were conducted or even were carried out confirmed that 5% of the incomes of major industrial nations are expenditurized or even are expensed or is expensed to the corrosions, whether in trying to diminish the corrosion or even trying to trying to escalate the corrosion or even trying to maintenance or replacing the equipment that actually corroded so much that leads to display or exhibit the disability for further usage. Or even exhibit the disability for the equipments to be furtherly used. There are many aspects, or even there are many forms of corrosions, and divided as follows. According to the nature of the corrosive media, يعني حسب طبيعة التآكل، صور التآكل الآن. A. According to the nature of the corrosive media. According to this, we can divide the corrosions to a wet and dry corrosions. According to nomenclature here, so the wet corrosions, or in the wet corrosions, is very necessary for the moisturized or the humidity or liquids to be exist. Just for this to happen, or just for this to take place. يعني مبتل من اسم التآكل مبتل، إذن يجب أن تكون هناك سوائل أو رطوبة. While it does not require for the dry corrosion, it does not require. This does not require for the dry corrosion to take place. Usually, the dry corrosion takes place at the elevated temperature between metallics and gases, at the interaction between any metallics or even aerosols or gases, as well as or as the way it happens at the smoking spots. كما يحدث في المداخن. B. The second aspect, or the second form of corrosion, occurrence, أو النوع الثاني أو الصورة الثانية الشكل الثاني لحدوث التآكل. The corrosion mechanism going along with the corrosion mechanism taking place, or the corrosion mechanism occurrence. According to the course of the tracks at which the corrosion process is actually going along with. And according to this, the corrosion will be divided into chemical corrosion and the chemical corrosion and electrochemical corrosion as well. G. The third form of the corrosion occurrences. According to the metallic appearance corrodedly, or even according to the corroded metallic appearance. In this case, we can divide the corrosion into a homogeneous corrosions occurs at the entire metallic surface completely, and the localized corrosions, or even concentrated corrosion, in this case concentrated in a specific spots or even specific areas. After we know that the corrosions and the form of corrosions, we just gonna have to study now highlights or even the most common types of corrosions, which is, by the way, the electrochemical corrosions of metals and the metallics. In order to understand and comprehend this corrosion, fundamentals have to be known that we already mentioned in the chapter 1, such as the atom, the molecules, as well as the electron of equivalence, and the metals and the ions. We're going to rest, or even we're going to list the fundamentals as we do now. صور التآكل هنا مبينة كما بيناها لكم. إذا صور التآكل يمكن أن تحدث يمكن أن تحدث نتيجة ميكانيكية التآكل، أو تحدث كمظهر الفلز، أو كنتيجة تحدث لكي أو لكون الفلز مبتل أو جاف، يعني يكون المادة الفلزية أو المعدن موجود في وسط سائل أو موجود في وسط جاف. هنا من الممكن أن يحدث التآكل بكل تأكيد. كذلك كما ترون الآن في الفقرة 1.5 here, as you can see right here in the article 1.5, the reduction, the conception or the concept of reduction and oxidation، يعني مفهوم الاختزال والأكسدة كما ترى. The article 1.5 here is actually very much interested about the reduction and oxidation at the same time. As we already mentioned كما ذكرنا من قبل previously من قبل, so the atoms will be denoted as the positive ions when it loses electrons. يعني الذرة تسمى الأيون الموجب عندما تفقد الإلكترونات. and will be denoted or will be termed as the negative ions when acquiring electrons. وتسمى الأيون السالب عندما تكتسب إلكترونات. The electron acquirement will be denoted as, or will be called as reduction, and the electron loss or electrons loss will be denoted as oxidation. This is really commonly known at to all human beings, and very commonly known by or very commonly known worldwide. The reduction and the oxidation at the same time. Article 2.5, the mole. Article 5.2, the mole is the quantity of mass or even the quantity of substance at which consists of an amount of, or at which consists of atoms and molecules in the amount of 6.023 by or times 10 to power 23 atoms or molecules. هي كمية المادة التي يوجد بها أو تتكون من كمية من الذرات أو الجزيئات مقدارها 6.023 في 10 أس قوة أو 10 إلى القوة 23 ذرة أو جزيء. والعدد الذي ترونه أمامكم, and as the digit here, or even the amount or the quantity as you see right here in front of you, as you can see right here in front of you, يعني العدد الذي ترونه أمامكم هو مقدار Avogadro or Avogadro's number or Avogadro's quantity. نفسه Avogadro's quantity. إذن Avogadro quantity هو المول. And this is against the nature of the material, or even against the nature of the material spartness. Here, some materials are spotted in the form of atoms. Materials are spotted in the form of atoms, and the materials can be spotted in the form of molecules as well. And the number, or even the digit, is denoted as Avogadro's number. يعني طبيعة تواجد المادة. بعض المواد توجد أو المواد توجد على هيئة ذرات، والمواد توجد على هيئة جزيئات. ويسمى العدد الذي أشرنا إليه, and the digit that we actually already pointed at is actually denoted as Avogadro's number. يسمى بعدد Avogadro. Mole is defined and is called the molecular gram or the atomic gram according to the nature of the material coexistence. يعني حسب طبيعة تواجد المادة. Or according to the nature of the material formation, as the molecular weight or even the atomic weight estimated by grams. The water, for size, or even H2O contains or even molecularly weighted as 18. يعني يحتوي على وزن جزيئي أو موزون جزيئيا بمقدار 18, which is the number, or better to say, which is the number of protons and neutrons completely present within, or even completely present in the molecule. Completely present at the molecule. هو عدد البروتونات والنيوترونات الكلي في الكلي الممثل كليا في الجزيء. البروتون والله. Consequently, the molecular gram of water is 18 gram. E.g. ومعنى ذلك إنه إذا كان لدينا 18 gram, in case if we have 18 grams of water that contains, so they are, or they will contain of 6.023 times 10 to power 23 molecules of water. يعني فإنها سوف تحتوي على عدد أفوغادرو من الماء أو عدد أفوغادرو جزيء من الماء. It contains an Avogadro's number molecules of water. The Article 5.3, the electrolytic solutions or even the electrolyte, denoted as the electrolytic solution or even the electrolyte. The electrolytic solutions can be defined as the electrolytic solutions that can conduct electricity, by ionic mobility. يعرف المحلول الإلكتروليتي بأنه المحلول الذي يوصل الكهربائية عن طريق حركة الأيونات. Or the electrolyte is actually can be defined as the electrically conductive solutions by ionic mobility. يعني يعرف المحلول الإلكتروليتي بأنه المحلول الذي يوصل الكهرباء عن طريق حركة الأيونات. For size, or for example, the distilled water is actually very easily electrically conductive. Very easily electrically conductive. But in case if we add a salt to the distilled water, such as the salt of sodium chloride, or the even solid solutions, or even solution salts, here as sodium chloride NaCl, which turns to a positive ion and negative ion at the same time while dissolving into the water. So the electrical conductivity or the electrical conductivity will be substantially overwhelmed or be substantially optimized or enhanced. لكن هنا الماء المقطر يوصل كهرباء بسهولة. لكن إذا أضفنا له ملح مثل كلوريد الصوديوم, in case of we add a salt right to, or even in case of we introduce a salt to the distilled water, such as sodium chloride, which is a very much table salt, considered table salt, which will be converted lately or even converted subsequently into positive and negative ions while or at dissolution into the water. So the electrical conductivity, التوصيلية الكهربائية, will be substantially or even tremendously optimized or even enhanced. فإن توصيل الكهرباء يزداد أو يتحسن بدرجة هائلة كما ترون أمامكم. As you can see right here in front of you, we're about to go through, or we're about to study, or even we're about to visualize the article 4.5, the polar potential. يعني الآن سوف نحاول أن نوضح, clarify and disambiguate and visualize the article 4.5. سنحاول أن نوضح أو نتصور الفقرة 4 المتعلقة بالجهد القطبي, أو التي تتحدث mainly basically أساسيا عن الجهد القطبي. As you can see here for you, the electrized laminas, figure 1.5. Here, a lamina here, the lamina here, we're in the middle, and the lamina here at the leftward and the rightward. The rightward lamina contains a negative charge within the surface of the metal. And there's actually a positive charge at the surface, or in the interface between the aerosol media and the metallic surface, as you can see right here in front of you. So the second lamina, or this lamina at leftward or left-hand side lamina, negatively charged from within, or even interiorly negatively charged, يعني مشحونة شحنة سالبة من الداخل, negatively charged, and as well as positively charged from exteriorly. At the exact interface between the metallic surface as well as which comes in contact with the aerosol media or even with the atmosphere. Here, the positive ions and the negative ions, the positive ion at the metallic surface contained remains as the same, or as they are, but the negative change or even the negative formations of negative charge will be released or will be evolved from the metallic surfaces from within right into metallic surfaces interface and exceeding the threshold frequency, and they will be released right into the atmosphere onto the aerosol media interacted with the metallic surface exactly here, as you can see. So the positive ions or even the positive charge or the positive ions and the negative ions in the same time will be getting into a mix. They will mix with each other. إذن كما ترون أحبتي, هنا صفيحتين كهربائيتين, طبقتان كهربائيتين, two electrolyzed layer, electrolyzed laminas. هنا تحتوي على شحنات سالبة داخل سطح الفلز, وشحنات موجبة على السطح الفاصل بين الجو الغازي أو بين الهواء وسطح الفلز كذلك بانتظار التفاعل, wait for interaction. هنا الطبقة الثانية أو الصفيحة الثانية تحتوي على شحنات سالبة أو إيونات سالبة داخل سطح الفلز كما هنا موجود في الصفيحة التي درسناها من قبل, وشحنات موجبة على السطح الفاصل بين سطح الفلز أو في المنطقة الفاصلة بين سطح الفلز والجو الغازي أو الهواء, الجو الغازي وليس الهواء, الجو الغازي. وكذلك يحتوي الجو الغازي على أيونات سالبة. لذا فالأيونات الموجبة هنا عند التفاعل أو عند بدء التفاعل at the reaction commencement or at the reaction inception will interact with the negative charge. هنا الأيونات الموجبة سوف تتفاعل مع الأيونات السالبة بهذه وبالطريقة المؤمن إليها أو الطريقة الآن التي نتحدث عنها يحدث التفاعل التآكلي, at which at which, or the method we're actually talking about here, or even the kinetics or the mechanism that we actually studied here, or you can try to visualize here, or even to clarify and disambiguate that will result in the corrosive action, or the corrosive interaction between the metallic surface exactly at the interface between the metallic surface and the aerosol media, or even the atmospheric media. شكل 1.5 طبقتان الكهربيتان كما ترون. The electrized laminas. Figure 1.5, the electrized laminas, or the electric layer. Electrized layer. بسم الله الرحمن الرحيم. Here actually is actually here's actually, as you can see right here in front of you, a very highlighted topic here required to be concentrated for, which states as follows, or even stipulate as follows. يعني هنا موضوع مهم يجب أن نبحث فيه أو يجب أن ندرسه. إذا غمرت ساق فلزية, in case of any metallic stock was immersed or is immersed in electrolytic solutions, in any electrolytic solution or any electrolyte. يعني إذا غمرت ساق فلزية في في أي محلول إلكتروليتي, نجد أن بعض ذرات الفلز المتواجدة على السطح, we can only find that the metallic atoms coexist at the surface. يعني نجد أن ذرات الفلز المتواجدة على السطح, الذرات على السطح التي في السطح الذرات. And in case of contact or in contact with the solution, وفي حالة تلامس مع المحلول, which means the atoms are at the interface between the metallic surface and the electrolytic solutions. يعني ذرات الفلز المتواجدة على السطح في السطح الفاصل أو في المنطقة الفاصلة بين المحلول وسطح الفلز tend to dissolve to the electrolytic acid, or even tend to dissolve within the electrolytic solution. يعني تميل للذوبان في المحلول الإلكتروليتي. They are naturally, هي بطبيعة الحال لا تستطيع الذوبان. They can dissolve while being in the image of neutralized metallic atom. They can dissolve at the form of neutralized metallic atoms. يعني الذوبان على صورة ذرات فلزية متعادلة. لذلك, therefore, or thus, لذلك, they will be converted into a very positive electricalized ions, leaving the electrons at the surface of the metallic. لذلك فهي ستتحول إلى أيونات موجبة التكهرب, positively electricalized ions, leaving تاركة الإلكترونات أو إلكتروناتها, leaving their possessed electrons at the metallic surface. Therefore, نتيجة لذلك, as a result, an interface potential difference will be generated throughout the interface between the metallic surface and the electrolytic solutions. We can perform reproducibility for the tendency of the metallic ions to dissolve within the electrolytic acid. يعني يمكننا إرجاع ميل الذرات الفلزية. We can even restore the tendency of the metallic atoms to dissolve to the electrolytic acid, للذوبان في المحلول الإلكتروليتي. Whether the electrolytic was whether the electrolyte actually deal with here, whether it was an acidic acid or even a basic solutions, whether it was or even the electrolytic acid that we actually deal with, whether the electrolytic acid was or even whether the electrolytic solution or even the electrolyte here required to dissolve the metallic surface, or required to possess the positive ions or the negative ions from the metallic surface, or even interchanging ions between the metallic surface and the electrolytes that we actually deal with, whether the electrolyte is basic solutions or even acidic solutions. In the form of ions, we can even restore the tendency of the metallic atoms to dissolve to the electrolytic solutions in the form of ions to levitate, to elevate or levitate, or even to escalate the energetic content of the metallic ions of the metallic atoms of the metallic ions. يعني على صورة أيونات إلى ارتفاع محتوى الطاقة في الذرة الفلزية عن الأيون الفلزي. طاقة الذرة الفلزية طاقة أكثر مما يكون للأيون الفلزي. And its pursuit to reach more stable phase. وسعيها للوصول إلى مرحلة استقرار أو مرحلة أكثر استقرارا. Which means that the phase at which it will possess highest level of energy, or will possess as highest level of energy as possible, in order for the atom just to be stable, or in order for the atom just to be settle يعني استقرار, or stable يعني استقرار. It is commonly known that the entire spontaneous or the entire simultaneous variations flow in the direction or in the orientation or towards the orientation that leads to escalate the energy content of the atoms. من المعروف from the second law or even from the laws of thermodynamics, يعني من قوانين الديناميكية أو التحرك الحراري، من المعروف أن كافة التغييرات التلقائية تسري في الاتجاه الذي يؤدي إلى محتوى الطاقي للذرات كما ترون. We can even represent the dissolutions of the metallic atoms at the interface surface between the metallic surface or at the interface spot, or even at the interface between the metallic surface and the electrolytic solutions as follows. So we can equationally represent the dissolutions of the metallic atoms at the interface between the metallic surface and the electrolytic solutions with the following equation. M is the atom, is the stable atom here. Irreversible direction or irreversible reaction will lead to or will result in, يؤدي إلى, result in نفسها leads to بالإنجليزية. M plus Z plus ZE. M plus Z is the positive ion and ZE is the electron. As well as these are very much significant terms here for the equations portions or from the equations terms. هنا دلالات لمحتويات المعادلة. M is the electrically neutralized atoms prior to dissolution. Electrically neutralized atom prior to dissolutions, or pre-dissolutions electrically neutralized atom. أو الذرة المتعادلة كهربيا أو الذرة المحايدة كهربيا قبل الذوبان. M plus Z, M زائد Z, the post-dissolution or the a posterior dissolution atomic ion, الأيون الفلزي بعد الذوبان, carries an amount of Z of the electrically or even the positively electricalized charge. الأيون الفلزي بعد الذوبان يحمل عدد مقداره Z من الشحنات الكهربية الموجبة. Z تكافؤ الفلز is the metallic equivalence or even the amount of electrons at which the metallic or in which the metallic atom should lose in order to be converted or in order to turn to a positive ion, or in order to acquire a positivity or ion positivity for the atom here. I'm talking about the atom here mainly. يعني تكافؤ الفلز Z أو عدد الإلكترونات، يعني أي عدد مثلا 2 أو 3. تكافؤ الفلز أو عدد الإلكترونات هو نفسه تكافؤ الفلز التي يجب أن تفقدها الذرة الفلزية بالتفاعل. amount of electrons should be lose by the metallic atoms while interacting with the media or while interacting with the electrolytes in order to be converted or even in order to turn into a positive ion. E is the electron significance. يعني إشارة الإلكترون. The previous equation represents, or the formal equations dealt with, represents the electrochemical reactions occurs at the interface between the metallic surface and the electrolytic solutions. Whether the solution was actually basic solutions or even acidic solutions. The positive ions will be hidden to the solutions because the layer has the ability to dissolve. Because the ability is dissolvable, or even, as you can see, has the ability to dissolve. The electrons will remain within the metallic stock. The electrons will remain as the same or remain as they are in the metallic stocks. Progressively with time يعني مع تقادم الوقت أو مع الوقت the metallic ion, or the metallic on its own, will acquire a positive or even negative charge, and the electrolyte will be positively charged, and the potential difference will be at max, or the potential difference will be escalated، يعني ويزيد فرق الجهد بينهما. as well as leads or result in oscillation of the electrostatic interactions between the metallic ions or positively electrolyzed metallic ions and the negatively electrolyzed metallic surface, as well as this. So we can find the metallic ions will be accumulated at the surface or will be agglomerated at the surface to form a lamina or even a layer of positive ions. Will be very much with the positive ions, will be very much conjugated with the positive ions at the electrolytic acids. Will force them away and associate it or even interact with the negative ions, and will have a very distinguished interface called the, or denoted as the both electrolyzed lamina, or the both electrolyzed layers, as illustrated in figure 1.5. By increasing the concentrations of the positive ions at the interface, the positive ions will be transferred within, or be transferred or flew through the solutions with the diffusion action, by the diffusion action, which we already mentioned at the chapter 2, as you can see right here in front of you. Accordingly, تبعا لذلك, the electrical charge will be overwhelmed, or electrical charge will be increased. The positive electrical charge will be increased in the metallic stock. So تزداد تبعا لذلك الشحنة الكهربية السالبة في الساق الفلزية. Therefore, the negative electrical charge will be accumulated or even will be increased in the metallic stock في الساق الفلزية. The conversion of the metallic atoms to a positive ions and their separation will be easy at the inception, or in the inception, or in the commencement of the procedure. And even the task will be harder with the accumulation of the negative charge within the metallics, till it comes a point where the metallic atoms can't leave the surface of the metallic. Here, then afterwards, the potential difference magnitude, or even the potential difference amount, will stand between the metallic stacks, and also the electrolytic acid will remain stands and constant, and will be denoted as the equilibrium potential difference, or even the polar potential, which is a metallic nature and electrolytic solution dependent potential. Or, better for us to say, the polar potential is a metallic nature, or the metallic physicality, and the electrolytic solution's independent potential. Now, we can only conclude here that every time polar potentials increased, there was a significance of losing more atoms. There was just a significance of more atoms lose from the metals, or e.g. increasing corrosion. Here, the visualization of the galvanic cells at the article 5.5, or in the article 5.5, as you can see right at the article 5.5. المقالة أو الفقرة 5.5 هي تتحدث عن الخلايا الجلفانية. Not every metal has the same readiness for oxidations, or even has the same tendency for oxidations, or e.g., or better for say, losing their atoms, or their atoms lose of electrons. To clarify this, we can only find that the figure 2.5, you could review figure 2.5 for more illustrations means or even for more illustration visualization. يعني ممكن لكم مراجعة الشكل 5.2 لتصور أكثر عن المعلومة. At the left hand side there's actually an intrinsic iron, a pure iron, Fe, immersed in a solution of concentration 1 mole per liter. That means there's actually an aqueous solutions dissolved within the water, is about to be, or dissolved in the water, gram of the ferrous or even the iron salts dissolved within a liter, or dissolved up a liter of water. It's very commonly known when to dissolve a salt in the water here, it will be converted, or even the salt will be turned, or even the salt will experiencing a conversion to a positive ions and negative ions in the same instant. And the right hand side, or even rightward, there's actually a pure copper, a pure Cu, intrinsic Cu, that consists of a 1 mole per liter concentrations of the Cu salts, or the Cu aqueous salts dissolved within with water dissolved into. The copper and its solutions is separated by a very porous membrane. The copper and its solutions, and the iron and its solutions as well, are separated, or even are very much off each other by are separated by a porous membranes in order to limitate the blending of the solutions, and at the same time to complement the electric circuits, or even in the same time to integrating the electric circuits. As we, in case we attach the copper and the iron electrically, so the electrons will be transferred from the iron right into the Cu. Thus, just because the iron has more tendency to lose electrons, or even it has a polar potential, here, as you can see right in front of you, a whole integrated or even a whole complemented circuit. It contains a voltmeter to measure the voltage throughout or flowing through the circuit. Here, as you can see, right in front of you, the voltmeter. The voltmeter is actually indicating the 0.780 volt with 2 positive dipole, 2 positive reversible or inverse poles here, positive and negative charge. Negatively charged poles and positively charged poles, with the electrons can pass right through the metallic structure, even right through the wire, launching or even elevated, launching from the stack of Fe to the stack of the Cu, because the electrons are lost, can be lost by the Fe, or even elevated from the Fe as a result of interactions between the metallic surface, or at the interface between the metallic surface, releasing the electrons from metallic surface, exceeding or even overtake overcome the overtake the threshold frequency from the metallic surface as a result for interactions with the acidic media, or even the electrolytic media here, to the wire. So the wire will receive the electrons to flow right through to the voltmeter to indicate or even to measure, to gauge the voltage resulting from the elevations, or even resulting from the current or the voltage flow through the wire as a result for any interactions, or even the triggering or the motivation deducing the electric charge flow and carrying the electrons from wire through the wire here to the voltmeter to gauge the voltage transferred, and the as also the amounts of the electrons carried by the charge right into the Cu stack here, or even right into the Cu acidic solutions, or the electrolytic solutions, aqueous solutions of Cu salts. Here, as you indicate here, the salts here, and as well as here the salt solutions, and here the salt solutions, or the aqueous solutions for Cu and the aqueous solutions for Fe. Fe is actually acquiring 2 positive charges in the one mole here, as you can see, 1 mole and 1 mole for Cu. Cu is actually acquiring 2 positive charge, 2 positive charge releasing the electrons, and as well as the Fe is actually requiring or acquiring 2 positive charge gain from the media, or even by losing the electrons to turn to a positive ions here. So the corrosion will take place right at the interface between the metallic surface, as we indicated before, and the solid or the aqueous solutions, as an electrolytic coexist within the receptacle, or even coexist within the galvanic cell or the electric circuits. Here we're trying to gauge the voltage, or even try to gauge the entire mechanism with. This is the porous sheet, or the porous brain, غشاء مسامي. Figure 2.5, or figure 5, to the galvanic cells of Cu and Fe. Even Cu will have, even the Cu will have an ultra polar difference, or even an ultra polar potential difference, other than the iron, or other than the Fe. Consequently, the iron will be corroded at the left hand side, and the Cu will be increased as a result for the elevation, or even as a result for elevation of electrical flow, electrical current flow, or electrical voltage flow, carrying the positive or the negative electrons from the metallic surface of the iron right into the Cu, for the Cu just to increase, for the Cu just to be overwhelmingly increased by precipitating the Cu ions after configurate with the electrons at the surface, or in the surface, after configurate with the electrons in the surface. We can equationally represent the procedure as follows. We can equationally represent the procedure as follows. يعني يمكن تمثيل ذلك بالمعادلات الآتية. Fe, irreversible directions, or irreversible interaction, will result in Fe, positive ion, positively duality, or dual positively charged ion, dual positively charged ion, يعني أيون حديد, dual positively Fe charged ion, يعني أيون حديد مؤين إيجابيا بمقدار شحنتين, plus 2e negative, plus 2e negative here, 2 electron, as you can see right here for you, as well as the Cu positive E plus 2 electrons, acquiring 2 electrons, will be turned to more mass of Cu. Thus, in the galvanic cell, we will gain more mass for Cu by corroding the Fe. لذا في الخلية الجلفانية سنحصل على المزيد من كتلة النحاس عن طريق إذابة أو عن طريق تآكل الحديد. The figure 5.2 here, as you can see, right, denoted or even called the electrochemical cell, or the galvanic cell, where 2 metals are attached, 2 different metals, 2 way different metals of each other are attached, which they are while in electrolytic acid. While in electrolyte, the corroded side will denote it as anode, in this case the iron, or in this case the copper, and the opposite side, or even the opposite side, will denote it as cathode, in this case the iron. Since there is actually electron transference, since there is actually an electron transference, this means, or this indicates, there is actually a potential difference between the 2 cell halves, can be gauged by a voltmeter apparatus, figure or illustrated in figure 5.2. يعني الكاثود والأنود. الكاثود هو النحاس، الكاثود هو الحديد، والأنود هو النحاس. Good. Figure 5.2 disambiguates or even clarifies 3 theories about the way it happens in the iron is the electrochemical corrosion, indicates the electrochemical corrosion occurrence, and the way it happens within the Cu is an electroplating procedure, or an electroplating process, and the passage of electrical current himself is a chemical energy conversion to an electrical energy, which is basically the theory at which the battery is actually mechanized according to, at which the battery is actually mechanized according to. يعني هي العملية التي تعمل بها البطارية، ألا وهي تحويل الطاقة الكيميائية إلى طاقة كهربائية بحتة عن طريق العملية، عن طريق التآكل، تآكل الحديد بإضافة كتلة إلى النحاس، أخذ الإلكترونات من الحديد إضافتها إلى النحاس. هنا الدائرة الثانية، الدائرة الغلفانية الثانية، voltmeter here as you can see right here in front of you indicates 0.323 volt. 323 volt. We have here zinc, خاصين, and we have Fe iron. Here we're just going to have to increase the mass of iron by corroding the surface of Zn, or by corroding the surface of zinc. هنا سوف نزيد كثافة الحديد أو نزيد كتلة الحديد بتآكل أو عن طريق اختزال الزنك. ليس اختزال وإنما عن طريق أخذ الإلكترونات من الزنك. By gaining zinc electrons here, flowing right into the wire connected to a volumeter to gauge the voltage, or even to gauge the dipolar or the polar potential difference generated at the galvanic cells as a result for electrical motivations by the EMF or by the SEMF indicated before. The electrical charge of the electrical current or stream will flow right through the wire into the iron, carrying the electrons or carrying the negative electrons. Negative electrons in this essentiality will conduct or even will perform or carry out the accumulation mechanism to the Fe by increasing the mass or by increasing the shallow mass for the metallic surface of Fe. Here by acquiring or even donating the Fe two positive electrically charged ions of Fe to the surface by corroding the Zn, as you can see right here for you. This is a solid solutions, or even this is an aqueous solution of Zn salts, and this is an aqueous solutions of Fe salts, Fe positively, Fe duplex positively, or even Fe dual positively electrical charged, will acquire two, or even will lose two electrons, will turn to a positive ions of two or of dual digit, 1 mole and 1 mole, 2 mole of and 2 moles. Here Z as well as the those electrons here will turn to a positive ions, as you can see right here in front of you. The voltmeter is actually connected to a very different inversed poles, which are mainly consists of the positive, or even which are mainly as positive ions, or even the positive pole as well as the negative pole here, and the two different sides of the wire conformation. خلال تشكيلة السلك كما ترون. وهنا الغشاء المسامي. This is the porous membrane, or the porous sheet, placed in between to separate between the iron and the zinc metallic surface, or even and the zinc metallic surface. The figure 5.3 disambiguates or even clarifies the galvanic cells for iron and zinc. Figure 5.3, as you can see, as we illustrated before, disambiguates or even clarifies an electrochemical cells between the zinc Zn and the iron Fe. We can only find that the zinc will be corroded, will turn to an anode, مصعد. الخارصين يتآكل ويتحول إلى مصعد. Anode هو مصعد. And the other side, or even the opposite side, the iron will be the cathode. الكاثود هو المهبط. الحديد سيكون هو المهبط. And the potential difference will be reversible, or even the potential difference will be reversible as illustrated with the figure, or illustrated in the figure. That's the way we can only find thus we can only find that the potential difference at the galvanic cells. الحديد هو الكاثود المصعد, والخارصين هو الانود. So the zinc is the anode, المهبط, and the opposite side, which is the iron by the way here, is the cathode. Cathode هو المصعد, والانود هو المهبط. We can only find that the potential difference at the galvanic cells differs according to the type of material is used, and denoted as the EMF potential difference, or the electromotive force potential difference. Article 6.5 the SEMF the Standard Electrical Motive Force القوة الدافعة الكهربية المعيارية. A new article to be discovered, a new article to be visualized. يعني فقرة يجب أن يتم تحليلها بعمق. New article should be profoundly visualized, or even should be profoundly picturized or clarified. As you can see right in front of you, this voltmeter actually connected with a wire here, and the wire is two-sided released, and the other side is actually on the farther, or even the farther side is actually connected to a PT, a platen metallic surface here with an aqueous solutions of metallic salts, or aqueous solutions of the metallic salts. The aqueous solution is actually is concentrated of 1 mole, is actually concentrated at the amount of 1 mole or 2 moles with the positive ions of hydrogen gas. Hydrogen gas will be elevated, will be inserted, or even will be introduced within the system here in that mechanism. The iron or the hydrogen gas will be inserted or even introduced to the control volume here by using the mechanism indicated in the figure, as you can see right in front of you. The porous membrane or even the porous sheets is placed where it's supposed to be, and the figure 4-5 indications illustrates the half S cell, the half S cell, or the half standard, or the half cell, the half cell. حشو العيار حشو standard والله. Good. The SEMF is used actually to compare between the various metals according to their oxidability or their electron loss ability. And this procedure is done by using a galvanic cells with a half pole made of platen, which is a very right, with the electronic acid was concentrated, or with 1 mole concentration or 2 mole per liter concentrations of the hydrogen ions H positive. Hydrochloric acid, a diluent hydrochloric acid will be used for size here with passage of hydrogen gas within hydrogen gas at an atmospheric pressure, where the gas of hydrogen or the hydrogen gas will be propagated or even diffused at the metallic surface of platen, which works as, or even which would be mechanized as a motivative agent for the hydrogen to acquire electrons, as illustrated with the figure 4-5. The part 2 of the, or even the section 2 of the cells actually consists of the metal required to measure the potential for here, with addition or even in addition for the hydrogens will be in electrolytic or the addition hydrogens, as you can see right here in front of you, or positive ions disintegrates, or even the table 1-5 disintegrates or even clarifies the potential difference or intermetallic potential difference and the hydrogen pole, the SEMF, as you can see right here in front of you, commences with gold AU, which will be the less metallic tenderness, less tenderness metallics of losing electrons and to be corroded. The metallics will be denoted, or even the metallics will flow at the upper part of the table, or will be placed at the upper part of the tables, such as AG, silver, and the gold AU and platinum PT as noble metallics, or even as rare or singular metallics. More upward we hidden to the table, more metallics we get, more tendency metallic for oxidations, or more oxidizable metallics, or better more oxidizable metallics, e.g. losing electrons, such as manganese Mg and sodium Na and the potassium K. يعني هنا سنخصص جدول هو جدول 1-5 يعطي فرق الجهد بين المعادن المختلفة، يجب حفظه. It should be memorized. Very important and very essential at the same time. جدول 1-5 يعطي فرق الجهد بين المعادن المختلفة والقطب الهيدروجيني.
the table 1.5 illustrates the potential difference between the various of metals and the hydrogenic pole. The SEMF هو الهيدروجين pole. The SEMF is the hydrogen pole. The table commenced with gold, and the table commences with gold. Commences with gold. AU, which by the way will be the less desirable metals here in losing electrons and corroding. The metals at the upper part of the table will be placed as silver AG and gold AU. يعني المعادن التي في الجزء العلوي. The gold here will be the most desirable, or even the most as you can see right here, it commences with gold, AU, which is going to be the most tendinous metals of tendinous metals of losing electrons and corroding. The metals at the upper part will be placed at the table for size, or such as the AG silver and the AU gold and the platinum PT called as singular or even the noble metals. More upper we hit in the table, or more upper we travel through the table, more metals or more tedious metals of oxidation, or more oxidizable metals we can get. E.g. metals that actually tends to lose electrons extremely, as manganese Mg and sodium Na and potassium K. Here, better for estimation, يعني من الجدير بالذكر. Here, the diluent acid of hydrochloric will be presented for size here, for example, with the passage of atmospherically pressurized gas. Atmospherically pressurized, where the gas will propagate, or the hydrogen gas will be propagate or diffuse at the metallics at the flat metallic surface, which works as a trigger agent, or even as a trigger factor for the hydrogen to give electrons as illustrated, or even to donate electrons as illustrated, or to give electrons as illustrated in figure 4.5. Section 2 of the cell will be consist mainly of the metal, at which metal required to measure the potential for will be mainly consist of hydrogen gas. Hydrogen gas of the 1 mole per liter concentration electrolytic solutions of the positive ions, as well as here we're just gonna have to stop here. Oh no, we're just not gonna stop. We're just gonna have to flow right through. We're just gonna have to flow right through to the table we already talked about. Here is the table. Done. We already visualized to you. هنا الجدول الذي تحدثنا عنه يمثل المعادن وقابليتها، أو المقارنة بين المعادن وتكافؤها والقطب الهيدروجيني للجهد المعياري للخلية الجلفانية. ZN ألمنيوم Mg خرسين ألمنيوم مغنيسيوم صوديوم وبوتاسيوم. God. We can notice from the figure 20. We can only notice from the figure 22.5 and 3.5 and the table 1.5, if any two electrolytes, or if any two metals came in contact electrically by direct impact or by a conductive wires, the passive metal won't be corroded, and this will be only against the corrosions of the most effective or the more effective metal. Consequently, when designing a facility, or when designing a metal facility for size here, we should take in consideration selections of the metals and the way of their impact. This in addition to the way of erosion, as you can see right here for you, which will be subsequently mentioned. which we subsequently mention. There are many of notations, or there are many of essential notations at the electrochemical corrosions of metals can be tell or even can be delivered as follows. هناك كثير من الملاحظات الهامة في عملية في الكهروكيمياء. يعني المعادن يمكن سردها كالآتي. God. Well, A. The corrosion may take place by two different metals in two different electrolytes, or even an electrolytic solutions with no ionic metals. B. The corrosion may be done for a different components or even for a different combinations of the same metal with the same electrolyte. G or G3, a third point of the deliverance. The corrosion may take place for the same metal with the same electrolyte, such as the zinc, an acidic media, as illustrated in the figure 5.5. يعني قد يتم التآكل لنفس المعدن في نفس الإلكتروليت، يعني يتم التآكل نفس المعدن مع نفس الإلكتروليت مثل الخارصين في بيئة حمضية acidic media as illustrated كما هو موضح بشكل 5.5 in the figure 5.5. Good. Here's actually a contact or even an corrosivity interaction, or in corrosivity electrochemical reactions actually done or even are carried out at the interface or in the interface at the interface between the metallic surface of zinc and the hydrochloric acidic media. محلول حامض الهيدروكليك، وهنا نشاط تفاعلي بين سطح الفلز والحامض، بين الحامض وسطح الفلز يؤدي إلى الآتي كما ترون أمامكم. Figure 5.5 localization or localized corrosion of the metal with the electrolyte. يعني تآكل موضعي localized، تآكل موضعي للمعدن في وجود الإلكتروليت. Good. Well, article, very important article here to be denoted for, which mainly consists or even mainly correlated to the CCR computation. يعني الفقرة الآن فقرة 5.7 مهمة جدا ومتعلقة أو تتحدث عن حساب CPR، حساب معدل التآكل. The corrosion rate or even the CR is considered of the very essential intels that we should know. يعني يعتبر معدل التآكل من المعلومات الهامة التي يجب معرفتها. There are several methods here to calculate the CPR. We can only mention the calculate of the CPR as follows. يعني إحدى الطرق الشائعة أو الطرق الشائعة هي حساب معدل اختراق التآكل كالآتي: corrosion penetration rate CPR equals to KW. KW will be converted to raw AT. W is the loose weight of the corroded mass. Lost weight of the corroded mass. Lose weight. I lost. والله. T. Here the T, as you can see right in front of you, the time at which the losing or the loose weight is measured with. The time at which the loose weight is measured with. يعني الزمن المقاس فيه الوزن المفقود. أو الزمن المقاس معه الوزن المفقود. Rho is the mass density كثافة المادة. A is the surface area of the corroded susceptible area، المساحة السطحية للمساحة المعرضة للتآكل. K is a constant according to the units used. Constant according to the units used. يعني مقدار حسب الوحدات المستخدمة. In case if we calculate W by milligram and the density by gram for each cubic centimeter and the area by the square centimeters and the time with hours, the K will be in the form of 87.6 to give a corrosion penetration rate by millimeter for each year. To give, or even to yield a CPR, corrosion penetration rate, for the millimeter for each year, by the millimeter for each year. يعني إذا حسبنا الدبليو الويت بالملي جرام والكثافة بالجرام لكل سنتيمتر مكعب من المادة، والمساحة أو لكل سنتيمتر، يعني مو حسبنا الحين قاعد يقول الكثافة، والمساحة بالسنتيمتر المربع والزمن بالساعات، تكون الكي كالآتي. قلنا أنه الكي هو حسب الوحدات المستخدمة. كي تكون 87.6 لتعطي CPR أو معدل اختراق تآكل ميم أليف تاء معدل اختراق تآكل بالمليمتر لكل سنة، مليمتر لكل سنة حسب المعادلات التالية. مثال على ذلك، مثال عن ذلك، حشو المعدل والله استغفر الله، حشو المربع والله. Example: a cube of iron or a ferrous cube مكعب حديدي with a lateral length of 1 centimeter، طول ضلعه 1 سنتيمتر، placed or even lies at the base in electrolytic acid for 200 hours. يعني موضوع على قاعدته في محلول الكتروليتي لمدة 200 ساعة. إذا كانت كثافة الحديد، knowing that the iron density is 7.87 gram for each centimeter cubic, for each cubic centimeter, and if the weight loss in this interval is 0.2 gram, calculate CPR. The solution by using the equation CPR equal to KW and equal to rho AT. Good stuff. 87.6 K will be denoted as 87.6 will be accounted as 87.6, which is best value there is. Best value there is actually best value there is for the K. And the W is 200 milligram, and the rho is 7.87 gram for each cubic centimeter, and the T is 200 hours. For the corroded area, the cubic has 6 faces. So the cube is very much convex regular for polytubes. Convex regular for polytubes has 6 faces, lies at the base, and consequently so the area susceptible will be 5 faces only. The face or even the frontal is about to be a square lateral length of 1 centimeter. Is a square of lateral length 1 centimeter or 2 centimeters. Accordingly, we're just going to have to solve as follows. يعني يجب أن نحل أو يجب علينا أن نحل تبعا لذلك، تبعا للمعلومات المعطاة. 5 equal to 1 times 5 equal to A square centimeter. CPR equal to 87.6 K by 200. 200 هو T. 7.87 by 5 رو كثافة الحديد 7.87 by 5 times 5 يعني في 5. المساحة في 200 في T في 200. المساحة هي T لأن المساحة حسبت هنا وجه، مساحة وجه في عدد الأوجه. The area of the face times the faces corroded أو وجوه المعرضة للتآكل equals to 2.22. Consequently, the CPR is 2.22 millimeter for each year. Millimeter for each year. بالتالي فإن معدل اختراق التآكل كما موضح هو 2.22 ملم لكل سنة. حشو بالمربع والله. Metallic protections from metallic protections. Here, as you can see right here in front of you, there are many means. Actually, many means are used for corrosion. The most common are the plating and the cathodic protection. The plating. The purpose of the mean, or the purpose of the indicated mean, is to isolate the metal of the outer media by using a layer will inhibit the metallic ions to dissolve within. Will inhibit the metallic ions to dissolve within. There are actually three types of platings, which are the metallic platings and the organic metallic platings, as well as the organic platings. Article 1185. The metallic plating is usually electrical plating, and we just weigh the electrical plating idea at the galvanic scale. Typically, the metal required to be plated with a further metal will be placed in electrolytic acid that contains metallic solutions for the electrolytic or the metallic solutions required to be plated with. Then electrical current will be passed to the original metals electrons, where the electrons will be configured with the ions of the plating metal to form a very surface layer, and the plating metal may be of more active mass, or even will be maybe of more active material, so will be corroded just instead of the original metal. As a result, for this, for size here, iron plating with zinc, or the plating will be as the same as the metal used between them both for each other. Has the plating or has the auto plating particularity, أو يكون اطلاع نفسه له خاصية اطلاع الذاتي, or even the same plating has the auto or even the self plating particularity. We can only notice that, such as, or for example, that the aluminium Al is more active than the iron Fe. You can take a look at the table 1.5 here. This is the hydrogen pole or even the standard pole potential relevance, or the standard potential comparison, and the different material equivalence, but it won't be corroded easily. Due to the presence, or even due to the aluminum oxides layer for the surface that protect the metal. Aluminum oxide, the alumina layer in the surface that protects the metal. Article 1285. The organic metallic plating, or the organic plating, Article 1385, will be usually by a polymeric materials, which gives a very thin layer here, or thin film, commonly used worldwide. وهي أكثر الطرق شيوعا. الحماية الكاثودية أو الحماية المصعدية. Article 285. Article 285, the cathodic protection. The main purpose of the means here to be used is to supply the metals with the electrons so much for the metal atoms won't be converted into dissolved to the media. The electron source will be either electrically or even a more active metal electrically connected with the metal required to be protected. The more active metal is actually usually denoted as the sacrificial anode, or even the sacrificial material. المادة المضحي. The figure 6.5, illustrated in figure 6.5. If you want to know more idealistic concept here about the cathodic protection, you can only review the figure 6.5. إذا أردتم معرفة الكثير أو فكرة معمقة أو فكرة كما ترون تفصيلية عن الحماية الكاثودية، يمكنكم مراجعة جدول 6.5. Illustrate a cathodic protection with a sacrificial anode, where a metallic facility is actually connected, metallic facility of steel connected with more active, or a metallic facility of iron. Metallic facility of iron is connected with more active cathode, which is our magnesium, by the way, pumps the magnesium, or even the magnesium will thrust electrons to the facility and acquire a very positive ions, or even denotes, or even supply a positive ions to the media, the magnesium, as you can see right here, and the facility will remain as the same. This is a very example for the cathodic protections by sacrificial material. شكل 6-5 الحماية الكاثودية عن طريق المادة المضحية كما ترون أمامكم. We actually do have a conductive wire here connected between the facility of iron or iron facility right into the sacrificial material, or right into the media, or even released right into the media. The magnesium will release a positive ions here, and the covered wire is actually used mainly or basically to transfer electrons by donating or by supplying positive ions to the iron facility, as you can see right here in front of you. Good. As you can see here, a summary for chapter 5. We're identifying this unison corrosion typically, and the most important types of corrosions, which are the electrochemical corrosions of metals. And the electrochemical corrosion of metal is studied by using the polar potentials and the galvanic cells, or the basic ways, or we highlights. This cells actually represents the theory of the electric plating, as well as the electrical battery and the electrochemical corrosions. Then we highlight the galvanic cells, or the standard galvanic cells, and the way that metals is actually assorted with according to their activity. We do big ways that the noble metals, such as the gold AU and the platinum PT, are the most packed or as the most noble metals to be used by corrosions. We only highlight afterwards the calculation of CPR, the corrosion penetration rate. Then finally we highlight the ways to protect the corrosion, as well as with big ways the two main ways to protect for protections, which are mainly or basically mentioned as plating and the cathodic protection. تم بحمد الله.